Dear friends, once again welcome. Now let us discuss about special conditions for the Truss uh, Truss analysis. So first one, identification of zero force member simply by inspection without calculation. If any joint is identified without external force acting on it such that the joint is formed by three members and two of them are collinear, then the third non-collinear member should be identified as zero force member. So let us take example in this structure. Example 1 is here and this is the truss. Okay, and you see the structure and identify the joint with no external load. Okay, so what about this? Here joint A, no external loads, but only two members are there. Here three members are there, but external load is here, so not to consider this joint. And the joint E, four members are there, so not to consider this joint. Okay, joint D, you can see external force, this one is there, so not to consider this joint. So the remaining joint F, so let us consider, and the FBD, this is the FBD drawn here. So at the joint F, you can see the vertical member, this one is non-collinear. It is non-collinear. Okay, and what about other? This one, this is one member, this is another member 2, and this is the member 3. So member 1 and 2 both are collinear. Okay, means if we show through the direction, so in this way we can show. So what will be then here? FDF, as per the condition, FDF is equal to 0. And what about this? So it will be, because it is collinear, that's why FEF is equal to FBF. So in this way we can minimize the calculations. So now let us take the another example. In this structure you can see have to identify the joints which satisfy the condition. So starting from the joint A, so obviously external load is there, so no, this joint is not selected in. What about at joint B? So at joint B it is drawn here. So see here, two members, this one and this one, both are collinear, but the third member is not collinear. That's why this is equal to this force member, that is the internal force, is equal to 0. Okay, and satisfying the same means extending the same criteria. If it is equal to, this force is equal to 0. Okay, so what about the same condition is here? This one. Okay, so F CE it is, and it is F AC, you can write, and this is equal to, okay, because both are collinear. But what about this third member, this one will be equal to 0. Similarly here, now the third is at the joint D, this one, so this will be 0. Now come to the joint E. What about here? So this member will have 0 internal force. So in this way, see how we have minimized the calculations. That's why working hard is not enough. Working smartly matters a lot for the success you can save your time. So be smart. So continuing our discussion now, the point 2, we are talking about special cases. So in which point 2, so as per this, if any joint is formed by two non-collinear members without any external force acting on it, then both the members are identified as zero force members. So let us take an example here, this structure. So how many joints are there? So 1 2 3 4 5 6 7 joints are there. Number of joints means 7. However, it is not required to identify. We have to identify the joint which is not subjected to external force. Okay, so just by observation you see, बी पे देखेंगे तो बी पे आपका दो फोर्सेस है, लेकिन इंटरनल फोर्स इज देयर, मीन्स सपोर्ट्स आर देयर, ए पे भी सपोर्ट्स आर देयर, एफ पे कोई एक्सटर्नल फोर्स नहीं है, बट दे आर फोर मेंबर्स, दिस वन दिस वन दिस वन दिस वन. Similarly, at G, three members are there, and W load is acting at G, and at E, F2 external force is there. So what is remaining here? D. Just observe here, and this joint D is drawn here. The FBD free body diagram is drawn here. So you can see here the joint is there is no external force is acting at the joint D, and the other two members are the non collinear members. Okay, so as per the condition, both the means forces FCD and FDE is equal to 0. The same we can extend here in this structure. This is the another structure here, by just seeing the joint A. The joint A is not subjected to any kind of load, either external or internal, or the reaction supports. Okay, A पे कोई supports नहीं है, okay, कोई external load नहीं है, so that's why we are selecting the joint A and उसका FBD. Let us draw here. So this one and the another member which is inclined, and both are non-collinear, and the joint A is not subjected to any any force. That's why both the forces are 0. Observe joint A, both the forces F AC is equal to F AE is equal to 0. Now let us discuss about the point 3. As per this, if any joint is formed such that only four forces are acting and are collinear in pairs, then each collinear forces are equal. So as per this, the example is here, and identify the joint जहाँ पे चार मेंबर्स हो और पेयर में आपका means collinear home. So identifying, see here, this joint is not eligible, and what about joint F is also not eligible, joint D is also not eligible, B तो eligible है ही नहीं, joint A is also not eligible. What about joint E? What about joint D? ठीक, joint C is also not eligible, क्योंकि आप देख सकते हैं this one and this one both are collinear, but एक ही only one pair is collinear. But what about this one, both are not collinear. So only the eligible joint is here E, which is drawn here. Okay, so you can see here the F2 is acting at the joint E, and this is the force member FEF. Okay, and another members FCE and FEG. So as per the observation, observe joint E, and as per this F2 is equal to FEF, and FCE is equal to FEG. Here we are not saying कि कोई मेंबर्स जीरो फोर्स मेंबर होगा। हम ये कह रहे हैं what we are saying collinears, there are two pair of collinears and the each pair will have the equal magnitude, and the magnitude may be any magnitude. So in special cases, the fourth point, the very important point, so if a given truss is symmetrical in geometry as well as in loading and support, then support reactions are symmetrical and forces in members on half side of symmetric are equal to the forces in members on the other half. तो as per this क्या बोला जा रहा है, if this structure is geometrically symmetric हो, loading condition as per the loading, तो देख सकते हैं कहाँ पे सेंटर पे, स्ट्रक्चर के सेंटर पे the external load is acting and supports, you can see here the support at end A and at B, तो just mid पे आप देख सकते हैं ये जो है सिमेट्रिक है। सिमेट्रिक मतलब यहाँ से अगर F से आप देखें तो 2L डिस्टेंस A है। Similarly, the joint B is also 2L distance from the joint F. तो geometrically symmetric है, loading in view of loading also symmetric, support reaction wise also symmetric. Okay, so what is saying, then in this case reactions and forces, so half of the, after getting the forces, half of the members means these members, okay, so this will be equal to the means another half of the structure. Similarly the support reactions आप देख सकते हैं RA is equal to RB. Similarly FAC you can see here where it is, so we're talking about this member is equal to FBG. तो आप देखिए देख सकते हैं इसका सिमेट्रिक देखा जाए तो AC is equal to BG. Similarly FAD, now we are talking about this one AD, so AD के इक्विवेलेंट क्या हो जाएगा आपका, ये आपका हो जाएगा FBH in this way. So no need to calculate all the forces, no need to waste our time, ठीक है. In this way we can minimize our time smartly. The last very important point that is related to cantilever truss. So in a cantilever truss, support reactions are not required for the analysis of the truss. Analysis can be started from the extreme end of the truss. So we should know what is firstly the cantilever beam. So this is one end is fixed and the other end is free, means no support is there. However, there may be the external loads like P here. Okay, so the similar condition we are getting here, the truss structure, the supports at the ends, one side at the joint G and the joint F, the whole whole structure you can see is supported by this fixed end. Okay, so as per this, not to start means not to calculate the support reactions until unless it is not asked in the question. ठीक है, सो कहाँ से स्टार्ट करना है, देन द फ्री एंड फ्रॉम द ज्वाइंट ए वी हैव टू स्टार्ट अवर एनालिसिस. ठीक है, चाहे तो आप ऐसा भी कर सकते हैं, लेकिन इससे क्या होता है मीन्स कैलकुलेशंस, मोर कैलकुलेशंस रिक्वायर्ड, it takes more time. However, you will get the same answers you will get, but why to waste our time? Okay, that's why we can start from the joint A. So in this way we can minimize the time. So in this way smartly we can analyze the truss structure by identifying the zero force members, by identifying the collinear, and by identify the pair of collinear structure members in the structure by identifying whether the cantilever truss is there. Then from where we have to start our calculation. No need to calculate the support reactions. And also suppose a structure is symmetric, so half of the portions means force members we need to find out, other half will be same. Okay, as we have discussed.